Any segment is the sum of its parts. What do I mean by that? Go ahead and, on the side right here, go ahead and put over for an example. Like, flip over your page now, and let me give you an example. So go and write over. This way, you know when you look at your notes, there's an example of it. Go ahead and draw a segment. A, B, and C. So this is on the back side now. You just wrote over. Oops. You wrote over to flip over so you can see an example of this. And now go ahead and draw a segment here. No. Think of what it says here. Any segment is the sum of its parts. Right? Backside, Franco? Or are you doing it on top? Picture, the backside? So watch, look at what the segment addition postulate says now. So we're on the backside right now, right? Do that later. Right now you're focusing right here. Come on, come on. What's the big segment called right here? Can someone name me the big segment? Watch this. AC is equal to, what are the two small segments? And, thank you. That's all it means. Look at, that's the segment addition postulate. Look at how obviously true that is. That's why it's a postulate. It's so obvious. It doesn't need proof. The big segment is equal to the two small segments added up. That's what segment addition postulate means. No biggie. Let's add one more now. The next one's called the angle addition postulate. The first one's segment, the second one's angle addition postulate. Watch. Angle all right. Just two proofs after this. Gosh. Angle addition postulate. Right, Franco? Angle addition postulate. Last one of the day. How do you think this is going to state? How would I write this? So it's worded exactly like the previous one. Instead of segments, we're dealing with angles. Any angle is the sum of its parts. That's pretty obvious. And I'm going to draw a picture right now again. Any angle is the sum of its parts. Put an arrow to flip over for an example. Or Frank will put it on top, which is fine. You can put it wherever you want. They're your notes, so I can care less. Here we go, watch. Go and draw yourself an angle with two angles inside of it. Let's call this P, Q, R, and then this one S. One more time, say it again. Wait, name me the big angle first. Thank you. So go watch this now. The measure of angle PQS, that means the degrees, is equal to the two small ones, huh? Thank you. So PQS is the big one, is equal to this small one plus this other small one. You with me, Rodriguez? So PQS is equal to the measure of angle PQR plus the measure of angle RQS. Nice. There it is. That's the angle addition postulate. No biggie, no biggie. Let's do 2 quick proofs and we're done. All right. RQS. And notice those are the 2 small angles, right, Rivera? Yeah, RQS is this one, this angle. RQS, that's this angle. If you add these little angles up, they equal to the big one. That's pretty obvious. That's why it's a postulate. Postulate are like obvious truths. All right, example 1, you could put on a separate sheet of paper or on the back of this paper. It's up to you. I could care less. Here we go. Go and write example 1. Given. Ready? Segment AZ. Prove x is equal to 5. And let me give you the picture. Actually, for given, I'm going to write AZ is equal to 50. We're going to do a 2-column proof. And let's go. And what do you think? Okay. We're given that AZ, that's the segment AZ, from here to here is 50. We got to prove that x equals 5. But we got to do it with a 2-column proof. Watch this. So we're going to put statements and reasons. Okay. Give me a statements and reasons chart. We're going to involve ourselves in some serious logic now. Deductive proof now. I'm going to use Dodger Blue since they won yesterday and they're in first place in the whole major leagues. Yeah, they're number 1 right now. Yeah. First team will go to 20 wins. By the way, Chang, what's always our first statement? Chang. Look at this. AZ is equal to 50. You always start off with your given. What gives you the right to say AZ equals 50? Well, what gives me the right is it's given. Statement 2. So far, so good? Look what I'm going to do now on statement 2. I'm going to say, you know what? AZ is equal to AX plus XZ. Look at that statement. What gives me the right to say that? What did the judge ask you? What gives you the right to say AZ is equal to AX plus XZ? Give me an appropriate reason for that. Back it up. Give me an argument. What would you tell the judge? I'm not dealing with angles. Thank you, sir. What's the language? Right, it's the one we just did. Every segment's equal to the small parts that make it up. So I'm going to write segment, I'll abbreviate, segment addition postulate. Nice. Say it with me, Franco. You're doing good. You're doing good. We got to prove that x equals 5 in the end. That's going to be our last statement. What can I do now? Any ideas of what I could do? I have an equation. What can I do with this equation? Well, they're just a bunch of letters. Substitute. Let's substitute AZ with what AZ is. What is AZ? Someone besides Toscano. What is AZ? I'll come to you, Toscano. What is AZ here? What can I replace AZ with? Good try. What do you think, Cheng? 50. Look at AZ is 50. So look at, I'm going to rewrite this equation, but instead of AZ, I'm going to put 50. Instead of AX, what is AX according to the picture? How big is AX? Thank you. I'm substituting. And then XZ is 25. Look at that. I'm just substituting. What property allows me to substitute? Thank you. The substitution property. It's on page 2, I want to say, or page 1. I can't remember. You check. I don't care. You got to know where it's at. That's your law book. Substitution property of equality. Nice. Good job, Yvetta. How am I going to get x by itself now? What do I got to do to both sides? What would I subtract from both sides? Thank you. If I take away 25 from the right and 25 from the left, what's going to result? Watch this. 25 equals to 5x. What gives us the right to say that? Well, what did I do? I subtracted both sides from the both. Subtracted the same amount from both sides, so it's subtraction property. Of equality. I'm just abbreviating equality here, like always. Nice. So the fifth step now is actually 5 is equal to x, huh? Look at 5 is equal to x. Division property Are we done? They're telling us to prove that x equals 5. I got 5 is equal to x. What allows me to say that x equals 5 now? Just swapping the left and right. What allows me to say this now? What gives me that right? First I had 5 equals x, and now I have x equals 5. What do you think, Rivera? Or Chang or Franco? 5 is equal to x, and now x equals 5. I just swapped around the left and right. All I did is took one on the right, made it on the left one made it on the right. What property allows me to do that? What do you think, Rodriguez? Close. It's the one right before transitive. Symmetric. Symmetric says if you have an equation, you can just swap the left and right. Look at symmetric property of equality. Woo! It's a 6-step proof. Nice. Symmetric property equality. Awesome. Take 1 minute brain break. Get started on your assignments. 41 or 42. Rodriguez, after your brain break, meet me in the back so I can tell you what videos to watch.